It is September 4th, 1943, and the beaches near Westward Ho, in Devon, exist in a state of controlled chaos. The morning tide rolls in across the shingle, and gathered on the sand is what can only be described as a remarkable sight. Soldiers stand at a safe distance, notebooks in hand, while technicians make final adjustments to an enormous cylindrical device, roughly 10 meters long and weighing some 4 tons, constructed from solid steel and topped with an alarming array of rockets. What stands before them has no official name, only a designation: the Great Panjandrum. In precisely 40 seconds, they will attempt to detonate it. The engineer responsible for this machine, a man named Jeffrey Pike, watches with quiet confidence. He has convinced the highest levels of the War Office that this bizarre contraption represents the future of amphibious assault. What nobody in that moment realizes is that this single test will become so legendary, so improbable in its conception, that when German intelligence officers hear reports of its existence, they will dismiss it as Allied propaganda, a hoax so outlandish that no military force could possibly construct such a thing with serious intent. This is the story of how Britain, locked in desperate conflict and searching for any advantage against Nazi-occupied Europe, created something so strange, so seemingly impossible, that it would confound the very enemy it was designed to defeat. It is a story of innovation driven to the point of absurdity, of brilliant minds pursuing solutions that should never have worked, of an invention so peculiar that history itself would struggle to believe it was real. Yet, for a brief moment in 1943, the Great Panjandrum represented Britain's best hope for breaking through the fortified coastlines of occupied France. It was a machine born from desperation, refined through mathematics, and tested in the face of all reason. Its legacy would prove more enduring than anyone anticipated, not because it succeeded, but because it failed in such a spectacular and unforgettable manner. The problem. By the spring of 1943, the strategic situation facing the British and their American allies had reached a critical juncture. D-Day was still approaching on the horizon, and every military planner understood that the invasion of occupied Europe would demand the breaching of fortified coastal defenses unlike anything previously encountered in the history of warfare. Hitler's Atlantic Wall stretched from Norway to Spain, a continuous line of bunkers, pillboxes, barbed wire, and anti-landing obstacles specifically designed to make amphibious assault prohibitively expensive in human lives. The Germans had studied the lessons of previous landings, particularly the disastrous Dieppe raid of August 1942, which had cost the Canadians over 2,000 casualties in a single operation, and had drawn precise conclusions about how to render beachheads untenable. The existing methods for clearing beach obstacles were labor-intensive and dreadfully dangerous. Engineers would have to work by hand, cutting wire and clearing mines whilst under withering machine gun fire from fortified positions. Tanks could breach the outer defenses, but they were ponderous, limited in their maneuverability on soft sand, and vulnerable to concentrated anti-tank fire. Artillery bombardment could pulverize specific strongpoints, but the Allies could never achieve sufficient surprise to prevent the Germans from reinforcing threatened sectors. The very nature of the problem seemed to defy conventional solution. A beach assault required moving thousands of soldiers across open ground, whilst under fire from prepared positions at distances of 200 meters or less. This was not a puzzle that could be solved by merely applying more force in the traditional manner. It required something fundamentally new, something that could clear obstacles, suppress enemy fire, and provide direct support to troops in a single integrated system. This was the problem that occupied the minds of British defense planners in 1942 and early 1943. They recognized that conventional approaches would result in unacceptable casualties. An invasion of Europe could cost tens of thousands of Allied lives if the fundamental questions of beach assault were not solved. The United States military had begun developing specialized amphibious assault vehicles. True, but these were clumsy machines, slow and vulnerable. What Britain needed was something more audacious, something that played to British strengths in improvisation and unconventional thinking. It needed a secret weapon, or at the very least, something unexpected enough to disrupt German defensive preparations. The problem, however, was that the best minds in the British military had exhausted conventional approaches. Every new idea had been tested and found wanting. Something unprecedented was required. Something, in retrospect, perhaps altogether too unprecedented. The solution. Technical deep dive. The solution, when it arrived, emerged not from the War Office or the Ministry of Defense, but from the mind of Geoffrey Pike, a civilian scientist working within the military apparatus. Pike was the sort of figure who embodied a particular strain of British eccentricity during wartime, brilliant, lateral in his thinking, and blessed with the confidence necessary to convince senior military figures that improbable ideas were worth pursuing. His fundamental insight was this: if conventional obstacles could not be crossed, why not simply roll over them? The resulting concept became known informally as Panjandrum, a name borrowed from a Victorian nonsense poem and perfectly capturing the absurd grandeur of what was being proposed. The technical specifications were extraordinary. The device consisted of a steel cylinder approximately 10 meters in length and 2 meters in diameter, weighing approximately 4 tons when fully loaded. This cylinder was mounted upon 2 enormous wheels, essentially like a giant tin can on wheels, and the entire contraption was powered by a revolutionary propulsion system that existed nowhere else in the world. Running along the circumference of the cylinder, at intervals of roughly 30 centimeters, were 36 of the new 3-inch rockets recently developed for aircraft use. These were not arranged randomly, but precisely angled and calculated so that when ignited sequentially, they would produce a controlled, directional thrust. The engineering challenge was substantial. The rockets themselves, each capable of producing a thrust equivalent to roughly 1,000 pounds of force, had to be carefully timed so that their impulses did not destroy the device itself. Too much power applied asymmetrically, and Panjandrum would topple sideways or veer uncontrollably. Too little, and it would be immobilized by soft sand or beach obstacles. The solution involved an intricate firing sequence controlled by an electrical timing mechanism, extraordinarily sophisticated for 1943, requiring precise synchronization of multiple explosive charges occurring within milliseconds of one another. The main charge, a shaped explosive charge approximately 4 tons in weight and positioned within the cylinder's center, was designed to detonate upon impact with significant fortifications. The cylinder itself was constructed from steel plate roughly 12 millimeters thick, sufficient to protect the payload from small arms fire but vulnerable to anti-tank weapons. The manufacturing process was undertaken at secret facilities operated by the War Office Experimental Establishment, primarily at Aberporth in Wales. The precision metalwork required to manufacture the cylinder's body was subcontracted to specialist engineering firms across South Wales and the Midlands. The rocket mechanisms themselves came from the aircraft industry, whilst the electrical timing systems represented cutting-edge advances in military engineering. Security protocols were extraordinarily stringent. Only a handful of senior figures understood the full specifications of the device. The general assumption throughout the facilities was that they were manufacturing components for conventional artillery or demolition equipment. Not a single worker in any of the factories manufacturing Panjandrum's components saw the complete picture. This compartmentalization, absolutely necessary for security, meant that many engineers never understood precisely what their work was contributing to. Estimates suggest that the full development and initial manufacturing program for Panjandrum cost somewhere in the region of £200,000, an enormous sum in 1943, representing the annual salary of roughly 6,000 workers. However, the exact expenditure remains unclear, as records were partially destroyed following the project's abandonment, and the classified status of the work meant that budgets were deliberately obfuscated across multiple government accounts. What is certain is that by the summer of 1943, The first operational prototype was complete and ready for testing. Operational use. The test, conducted on September 4, 1943, remains one of the most comprehensively documented failures in British military history. The procedure was straightforward in concept. Panjandrum would be positioned on the beach at Westward Ho. Its rocket systems would be ignited in sequence, and it would race across the beach towards a fortified position where the explosive charge would detonate. The entire operation was filmed, partly for documentation purposes and partly because the scientists involved recognized that the footage might prove valuable regardless of the outcome. What occurred over the next 60 seconds would, quite inadvertently, become one of the most famous pieces of military footage from the entire war. The rockets ignited with a roar. What happened next can only be described as a loss of control that was both complete and immediate. The precise synchronization that theoretically should have driven Panjandrum directly forward instead created an asymmetrical thrust that caused the device to veer sharply to the right. This veering motion was then compensated by subsequent rockets firing, resulting in a trajectory that could charitably be described as erratic. Witnesses reported that Panjandrum appeared to be simultaneously accelerating and spinning, following a path across the beach that resembled less a machine of war and more a spinning top. The soldiers positioned along the beach, observing from what they believed to be a safe distance, began to scatter. Panjandrum approached the fortified position not in the controlled, purposeful manner envisioned by its designers, but in a chaotic, unpredictable manner that suggested it might veer in any direction at any moment. The impact, when it finally came, was anticlimactic. Rather than striking the fortification with the full force intended, the device clipped the corner of the structure at reduced speed. The explosive charge detonated, yes, creating a respectable crater and destroying a portion of the fortification, but the overall assessment from observers was clear. This had not been a success in any meaningful sense. The uncontrollable trajectory meant that troops advancing behind Panjandrum would have no certainty regarding which direction it would move. The psychological value, the shock and disorientation, which theoretically made up for the tactical limitations, was undermined by the fact that the device's erratic behavior made it seem more dangerous to friendly forces than to the enemy. Subscribe. Reminder. If you are finding this fascinating, a quick subscribe helps more than you know. The story of Panjandrum is just one of many extraordinary tales from Britain's war machine, and there are plenty more to explore. Comparative analysis. The Germans, when reports of Panjandrum reached them through their intelligence channels, responded with something between skepticism and contempt. German military planners had developed their own approach to amphibious assault, one that centered on concrete fortifications, interlocking fields of fire, and pre-positioned reserves capable of swift counterattack. When they were informed that the British military had constructed an enormous wheeled device powered by rockets, their initial response was disbelief. This was, several German officers suggested, precisely the sort of fantastic propaganda the British might produce to inflate their own confidence and demoralize German soldiers. A machine that large, that powerful, could not possibly be controlled effectively. It violated basic principles of physics and military engineering. Surely this was a hoax, or perhaps a misinterpretation of reports regarding some conventional vehicle. The British could not seriously intend to deploy such a contraption in actual combat. This disbelief proved to be both tactically irrelevant and, in a certain sense, a remarkable compliment. The Germans had become so accustomed to viewing British military innovation as a combination of pragmatism and conventional thinking that an idea genuinely outside the bounds of conventional possibility seemed to them implausible, even when reported by their own intelligence services. The Americans, by contrast, who were kept partly informed of Panjandrum's development, responded with polite interest and studied skepticism. American military planners were developing their own specialized assault vehicles. the LCVP landing craft, the Sherman tank with specialized variants, and viewed British pursuit of a fantastical wheeled projectile as a curious detour. What neither the Germans nor the Americans fully recognized was that Panjandrum represented something deeper than simply the pursuit of a particular technical solution. It embodied an approach to war that emerged from Britain's strategic position in 1943, a nation with declining material resources but undiminished creative intelligence, attempting to multiply the effectiveness of limited forces through unconventional thinking. The British were willing to pursue ideas that were genuinely mad if there was even a small chance they might work. This was not strategic thinking in the conventional sense. It was desperation dressed up as innovation. Impact and legacy. The historical impact of Panjandrum was, in the final analysis, minimal. The device never saw combat. No invasion force ever advanced behind a Panjandrum clearing, obstacles before them. The beaches of Normandy would be stormed by infantry, tanks, and specialized assault vehicles, but not by wheeled cylinders powered by rockets. Yet the impact of Panjandrum cannot be measured solely in terms of its direct military application. The device represents something more significant, a moment in military history when the pressure of conflict drove talented engineers to pursue solutions that transcended rational calculation. The psychological impact on those involved in its development was considerable. Many of the scientists and engineers who worked on Panjandrum felt a profound sense of vindication in its failure. It demonstrated, they believed, that they had pursued an idea genuinely at the frontier of possibility. The device had not failed due to incompetence or poor engineering. It had failed because the underlying concept, however brilliant in abstract terms, could not be made to work in the material world. This distinction mattered profoundly to those involved. They had not failed in their execution of an idea. They had revealed the limits of what was possible. In a certain sense, the legacy of Panjandrum lies not in any innovation that emerged from its development, but rather in the validation it provided for a particular kind of thinking. British military planners would continue, throughout the remainder of the war and beyond, to pursue unconventional solutions to apparently intractable problems. The Hedgehog anti-submarine mortar, the Sycamore multi-rotor helicopter concept, various experimental weapons and devices would all emerge from the same intellectual tradition that had produced Panjandrum. The idea that one should always attempt solutions lying slightly beyond what seemed possible became embedded in British military culture. Closing. We return, finally, to the beaches of Westward Ho on September 4th, 1943. The morning tide has receded. The smoke from the explosion has dissipated. Soldiers collect the fragments of the fortification destroyed in the test. Geoffrey Pike, the man who conceived of this extraordinary machine, watches the results being catalogued and photographed. He will continue his work in military innovation. Others will pursue other ideas, some practical, some fantastical, some existing in the territory between the two. But in this moment, on this Devon beach, something peculiar has occurred. Britain has attempted something genuinely unprecedented. The attempt has failed, yes, but the failure itself has become legendary. Panjandrum never became a weapon of war. It never cleared beaches or suppressed enemy fire or contributed directly to any tactical objective. Yet in failing as spectacularly as it did, it succeeded in becoming something far more memorable. It became a symbol of human determination to solve problems through ingenuity, creativity, and a willingness to pursue ideas whose success seemed improbable at best. When the Nazis heard reports of this wheeled cylinder powered by rockets, they dismissed it as propaganda, unable to conceive that anyone would genuinely build such a thing. Yet it had been built. It had been tested. It had failed, but it had existed. In its existence lay a kind of victory. Britain, facing an enemy with superior material resources and conventional military strength, had demonstrated something different. The capacity to imagine solutions that others deemed impossible, and the will to attempt their realization. The fragments of Panjandrum were collected after the test. The device itself was never rebuilt. The technologies that powered it were subsumed into other projects, other innovations, other weapons that would have far greater impact on the course of the war. But the idea persisted. Somewhere in the historical record, in classified documents gradually released to archives, in the memories of those who witnessed it, the image of that enormous cylinder spinning across a beach remained. It remained as evidence that in the darkest moments of conflict, when conventional solutions seemed inadequate, human beings were capable of imagining something genuinely new. Panjandrum failed in every practical sense. It solved no problem that required solving. It contributed nothing material to Allied victory. Yet in that failure lay something that no successful conventional weapon could provide. A demonstration that the limits of the possible were themselves far more expansive than anyone had previously believed.